All right, so let's draw a picture of this thing. Here's our 5.2 kilogram block. Okay, it's sliding to the left. We exert a force to the right. So let's draw, first we draw that force that it says here. Okay, so 5.50 newtons is to the right. Okay, and we're going to make everything to the right positive, everything to the left negative in this problem. Okay, and then from the first problem we figured out that the force of friction, the kinetic force of friction, is 7.1344. Okay, and that's a force that's opposing the slide, right? Opposite the slide. That's what kinetic friction does all the time, right? Is it just opposes the slide. It opposes any direction you slide. So if we're sliding to the left, this is to the right in this case. Okay, since we're to the left. So I'm going to draw a picture of that guy too. Okay, so 7.1344, right? And that's going to be a positive force. That'll be a positive force. The question is, how does this box slide to the left if all the forces are acting to the right? And the answer to that is that it's got mass, it's got inertia, it's got kinetic energy. Maybe it's going 60 miles an hour that way. We don't know the speed, right? It's going to continue that way. Now, for sure, with these forces acting on it, it's accelerating to the right. It's slowing down. It's going to stop, but there we go. Okay, so let's set up our F equals ma. So we got positive 5.50 plus 7.1344. And I'm not just throwing these in here. Okay, this is to the right. This is to the right. Okay, and then that equals 5.2 times A. All right, so 5.5 plus 7.1344 is 12.6344 equals 5.2 times A. And then we're going to divide both sides by 5.2. So divide by 5.2. I get 2.429, so A is 2.43, I'll say. Ta-da! Okay, so understand that that's a positive acceleration. It's sliding to the left, but accelerating positively, so it's definitely decelerating, right? Or going slower and slower. And that's because all the forces are acting opposite the direction it's going.